Okay, while we are on the topic of scientific notation, there's a slight flavor difference with another type of notation called engineering notation. And engineering notation is commonly used across all the sciences, and you've probably seen it uh, almost in your daily life and maybe not recognize that you were seeing it. All right, so what is engineering notation? So at first glance, engineering notation looks the same as scientific notation. So both are in this scientific notation format, all right, where you've got some decimal a times 10 to an exponent b. So let's differentiate between scientific notation and engineering notation using the diameter of the HIV virus that we've looked at before. So in scientific notation, this decimal for the diameter in meters, we could write it in scientific notation this way. So it would be 1.2 times 10 to the minus 7. And so it's 1.2 because that decimal number needs to be between 1 and 10. And the exponent b is a positive or negative integer. And so in our example here, it's a negative integer, it's negative 7. Now let's contrast that with engineering notation. And so you'll notice here it has the same format as scientific notation, but one thing you'll notice is that A is not between 1 and 10. And you'll also notice now the exponent has changed to negative 9. Now it was negative 7, and now it's negative 9. Well, why? So A now, instead of being 1 to 10, is now a number between 1 and 1,000. So 120 is a number that's between 1 and 1,000. And the reason why this happened is because we want b, the exponent, to be a multiple of 3. So, a multiple of 3 would be like 3, 6, 9, 12, 15, 18, 21, and so on. So we want to have this value of b to not only be a positive or negative integer, but also be some multiple of 3. Right, so that's how it changed by going from 1.20 times 10 to the negative 7 with scientific notation. When we move this decimal point over a couple to make that 120, we also have to change this exponent from negative 7 now to negative 9 to kind of keep that equivalence. And we need to do that to put this in engineering notation. So, one of the immediate questions is, well, why does engineering notation have this added stipulation of being a multiple of 3? And it's in multiples of 3 so that it can fit in line with the International System of Units and the prefixes that you'll find there. And so what do we mean by prefixes? So prefixes are little additions to the units of what you're looking at. And some of those little additions that come before the units are words like nano, micro, centi, kilo, mega, giga, and tera. So one of the ones you've probably seen is the centimeter. All right. So the centimeter you probably learned in elementary school with inches and centimeters. And so that's where centi came from. The prefix centi means 10 to the minus 2. So anywhere you see 10 to the minus 2, you can kind of put centi in its place. Another example would be like giga. So when you get a smartphone, the smartphone or your computer could have 16 gigabytes of memory, or it could have 32 gigabytes of memory. And so giga is a prefix from the International System of Units. And giga relates to 10 to the 9 bytes. So 10 to the 9, 9 is a multiple of 3. And whenever you see 10 to the 9, you can put giga in its place. Tera, so your computer might have 2 terabytes of storage on it. Okay. And so you've probably seen that in advertisements for desktop or even laptop computers or tablets. So you've seen these prefixes before. Those prefixes are related to multiples of 3 when it comes to engineering notation. So now you kind of have an idea of how engineering notation just has a few extra stipulations to make it that way, to make it different from scientific notation. So how do we go about multiplying, dividing, adding, and subtracting with engineering notation? So let's look, at an example that we've already looked at, and that is the diameter of the CD4 white blood cell, which is the host cell for the HIV virus. So in scientific notation, the diameter of the white blood cell is 4.80 times 10 to the minus 6 meters. And so what's convenient about this in scientific notation is that it's already in a multiple of 3. This exponent is already in a multiple of 3. And whenever we see 10 to the minus 6, we can exchange that 10 to the minus 6 with the word micro, or the symbol for micro is the Greek letter mu, right? And let me go to the next page to show you what I've included in your notes. And that's this table of International System of Units prefixes. So you'll see here to the left, we've got 10 to the minus 6. And 10 to the minus 6, you can convert that into the prefix micro and use the Greek letter mu as like shorthand for micro. So that's where that comes in. So we can then exchange this 10 to the minus 6 base and power with the word micro. So we've got 4.80 micrometers, right? So technically, this example here, this is in engineering notation, because this number is between 1 and 1,000. And we also have a multiple of 3 for the exponent. Now let's flip over to the diameter of the HIV virus. Now remember, this was originally 1.2 times 10 to the minus 7, but 10 to the minus 7 is not a multiple of 3. So we want to convert that to a multiple of 3. But the multiple of 3 we want to change it to is we want to change it to the same multiple of 3 that we're going to be subtracting or dividing it from later. So because the diameter of the white blood cell was in 10 to the minus 6 units, we're going to want to do that here as well. So when we convert 10 to the minus 7 to 10 to the minus 6, that changes the value of A to be 0.120. Now, 0.120, this is neither scientific notation strictly or engineering notation, right? So we are kind of breaking that convention for the sake of being able to add or subtract. Because then what we're going to be interested in is the result of adding or subtracting, is that in scientific notation or is that in engineering notation? All right, so that's what we're going to care the most about. So let's look at a question that we looked at earlier. How much smaller is the HIV virus than the cell it infects, which is the CD4 cell. And so what we need to do is take the diameter of the host cell and subtract from it the diameter of the HIV virus. And here we can see this is the diameter in engineering notation. Engineering notation where we're dealing with a base 10 with an exponent of 10 to the minus 6. And then we're going to subtract from that. We converted the diameter of the HIV virus also to be 10 to the minus 6, and that was 0.120 micrometers. So what allows us to, add or subtract 2 units in engineering notation is that they have the same units here, micrometers and micrometers. So when the units are the same, then you can freely add or subtract these values out in front of the units. So 4.8 minus 0.12 gives us 4.68. And then we can just reattach the units, micrometers, appended at the end. And you'll notice that now this answer is still an engineering notation. And so that's kind of what we care about in the end. If this wasn't an engineering notation or scientific notation, we'd have to do a little bit of adjusting to make that happen. But because we ended up with engineering notation in the end, it kind of made making this kind of breaking the engineering notation criteria, breaking that for temporarily okay. Now, we could have, by contrast, instead of working with micrometers, which was 10 to the minus 6, we could have done it with units of 10 to the minus 9 instead. And 10 to the minus 9 will give us the prefix nano, okay, or using a lowercase n to abbreviate nano. So instead of dealing with this math in micrometers, we could have done it in nanometers instead. So in order to deal with this in nanometers, it breaks the convention for engineering notation for the white blood cell, but it ends up being okay for the HIV virus, right? And when we kind of use it down here, we have the diameter of the white blood cell at 4,800 nanometers, and we're going to subtract that by the diameter of the HIV virus in nanometers. It's 120 nanometers. And when we subtract 4,800 from 120, we get 4,680 nanometers. So right away, this answer is not an engineering notation because this value here is not between 1 and 1,000. So we can make that, be a value between 1 and 1,000 by taking the decimal point here, moving it 3 spots, and changing it from nano to micro. And now we got that answer. So that's, an example of how we could work with a different multiple of 3, still do the adding and subtracting because they have exactly the same units with the same prefixes. And if we didn't like the answer at the end because it's not an engineering notation, we can make it so that it's an engineering notation. Okay. So that's how you add and subtract with engineering notation. So how about multiplying or dividing? So the next question we looked at was how many times larger is the host cell compared to the HIV virus? So this is going to be a ratio between the diameter of the white blood cell versus the diameter of the HIV virus. And when we kind of commit this division, we'll have what's called a scale factor. And we'd already converted the diameter of the white blood cell into micrometers. So that was 4.80 micrometers. And we converted the diameter of the HIV virus also into micrometers. And so that was 0.120 micrometers. And so what's important for multiplying or dividing, especially dividing, is to make sure that both units are the same. So here we've got micrometers, here we've got micrometers. And very much in the same way, when you're trying to simplify a fraction and you have a common factor you can cancel out, top and bottom, you can also cancel out like units. So since we've got micrometers in the numerator, we can cancel that out with micrometers in the denominator. And that leaves us with a unitless number, which is okay. That actually tells us that we're doing things right when you can cancel units in the numerator and denominator. So if you take 4.8 and you divide it by 0.12, you get 40. And so the host cell, the host white blood cell, is 40 times larger than the infecting HIV virus. So this is, a quick, brief explanation of engineering notation and how you can do GEJMDOS in engineering notation. And I wanted to draw your attention to this extra sheet, this table that I made, which gives you prefixes based off of multiples of 3 of 10. So here, 10 to the minus 3 is milli, like millimeters. If we go to the other side, so instead of having negative exponents, we have positive exponents. 10 to the 3 is kilo. So you've probably heard of the kilogram. That's 10 to the third grams. 10 to the 6 is mega. 10 to the 9 is giga. 10 to the 12 is tera. So like terabytes, gigabytes, megabytes. Those are all multiples of 3 for the powers of 10. And I kind of gave you some examples here with meter, gram, and seconds. And down below, to give you kind of a sense of scale, I put the sizes of things in these different scales down below. So feel free to kind of look at that if you're curious how big things are relative to each other. Okay, so that concludes the explanation for engineering notation. Let me know if you have any questions.